Next, Hwan Lee from Huan is going to talk about OpenGL SC, which might be a branch of the OpenGL family you've not heard of before. It's for safety critical markets.
Thank you. My name is Hwan Lee. I'm from Korea. So my company name is Huan. We are developing OpenVG and OpenGL related products, and mainly we are developing software. Okay. I will pass some. So my company is developing OpenVG software engine and OpenGL software engine, and we also have some kind of hardware related to OpenGL SC. So we are developing OpenGL SC related software solution and hardware solution. And then we are also a member of Kronos, and we are sales representative in Korea as a for Kronos too. And we also do this presentation. Originally, this presentation is made by Professor Nakun Baek of Gyeongbuk National University. So the mobile graphics lab, and the Professor Baek and my company are collaborating to developing OpenGL SC related product. And Professor Baek is one of the leader, taking a leader role in KITE Korea chapter also. Start that about safety critical profile of OpenGL. So OpenGL safety critical profile is designed for safety critical application industry like avionics and automotive or medical, maybe in other applications related to safety critical application. So minimize that driver size and the complexity to reduce the bug or problem or issues. And it is designed to, the main application of OpenGL SC is avionics industry. So in avionics industry, there is very high level of quality control of software in electronics and software. So that is a DO 178 A, B, C certification. Is very hard to pass this certification. At least it takes more than 2.5 years to pass this certification. So to pass this DO 178B certification, we should make, in every source code, we should make about half-page documentation. So if OpenGL function has so many features, and it requires so many documents. I think that if we use whole OpenGL features, then we need to make about 6 boxes of documentation is needed. So the many companies related to avionics electronics business decide to make the very slim and very minimized OpenGL feature to draw 3D graphics on avionics or the automotive industry. Okay, the first motivation is like this. It's the left picture is, I think, the traditional airplane cockpit the gauge cluster. So all gauges is made of all gauges are mechanical device, and it is very complex system, and sometimes it make trouble. But the purpose of OpenGL SC is drawing right picture. It's well organized and very light display for gauge cluster and dashboard display. The bottom image is that some kind of sample image of a tool generate the dashboard cluster or gauge cluster. The Astera technology is very famous in defense industry. They developed some kind of a authoring tool to gauge. Its product name is Scale. Scale generated that bottom three gauge cluster or no. It generate we design this gauge cluster with like some kind of Adobe Illustrator or something. They have some kind of a design tool. Then it generate that OpenGL SSC code. So if display device has OpenGL SSC rendering engine, then the scaled result can be compiled with that tool. Then it can be displayed. It can be displayed on display device. But many people, when I talk about OpenGL SSC, then many people ask to me, "Oh, then if we have OpenGL SSC, then we can draw." Okay, we can see that this image, and we can draw the 3D map or 3D the Therion display or some. We can draw the building on display, cockpit display. No, the answer is no, absolutely no. The OpenGL SSC is not designed for drawing 3D object or 3D complex 3D shape. OpenGL SSC is designed for drawing cockpit the gauge or simple indicator or simple quantity drawing. Okay, so the main purpose of OpenGL SSC is drawing gauge. Okay, please understand this. The main target of OpenGL SSC. Okay, so originally the OpenGL ES, we tried to making OpenGL S from using OpenGL ES, and then we were making the security critical profile, but actually the final result was very different from OpenGL ES. Okay. And the initial member and contributor of defining OpenGL SSC standard is some companies related to avionics and defense industry. And currently the component product is Huron Select SSC is only component product. And I will show some kind of briefly the relationship between some OpenGL and OpenGL ES and OpenGL SSC standard. The OpenGL 1.3 is the base of OpenGL ES 1.0 and OpenGL SSC 1.0, and OpenGL 1.5 is the base of OpenGL ES 1.1, and OpenGL 2.0 is the base of OpenGL ES 2.0, and maybe OpenGL 3.x will be base of OpenGL ES 3.0. Okay. In OpenGL SSC, there are totally 101 functions, and then they use GL begin and GL end paradigm. But you know that the recent OpenGL and OpenGL ES does not support the GL beginning and GL end paradigm anymore. But I think that in avionics business, they need to test the data one by one and so test the source code one by one line. So they try to use this scheme. And there is another additional feature is the single precision features, and very special, very strange feature is that they use the palette texture. You can remember you can remember that if you are working in the computer graphics industry, then you remember that 8-bit color palette, the display. So there is some kind of a 256 lookup table, and then we add some kind of indexed color. Then in each pixel has 8-bit data. Then we change it into RGB color. That scheme is, I think it's 10 years ago. It is disappeared, but in avionics cockpit display, it requires to display in some changes, some kind of some mode or emergency mode. So they add this palette texture feature in OpenGL spec, and optionally they have some kind of shared text palette and display list features. I'll show you some more detailed features. In geometric primitive, there is 0.9 line strips and line groups, but they excluded that GL polygon and GL part strip and GL part. Okay? So you cannot use this kind of primitive in OpenGL SC. Okay? And GL begin end scheme is still live in OpenGL SC. And then, Spotlight and two-side writing and multi-sampling is not supported in OpenGL SC. And you know that some avionics business hate fog, so no fog is supported in OpenGL SC. Okay. And to draw some kind of dashed line or dashed patterned fields, so they added that line strip and polygon strip. And there is some kind of a text pipelines, and at least 2 texture units must be supported by renderer. And then they removed that de-drawing and the logical operation of a frame buffer. And in case of drawing pixel, there are so many, the combination of the pixel format, but in OpenGL SC, the RGBA image only can be supported in OpenGL SC. Okay. And lead pixel also the RGBA color with unsigned byte only. There is also another special issue is with display list. So we can allocate and maintain the display list, but the very strange thing is there is no function for releasing allocated list, display list. I think it is because they thought that they don't need and they must remove this releasing display list feature, because as you know, all gauge cluster or dashboard should be, if we turn on the engine or if we turn on the flight, then the cockpit display must be turned on. And then until we turn off the airplane or car, it should be maintained. So if it is not maintained, it will make a big trouble. So they remove this kind of some kind of a religion of a location list does not exist as a feature of OpenGL SC. Sometimes it makes some trouble to nowadays car dashboard display has some kind of very beautiful features. So for example, sometimes it appears some kind of displaying GPS and map, and sometimes if the gasoline the fuel gauge is low, then there should be some kind of dashboard displaying that warning. But the problem is the whole list of the display should be fixed. So sometimes it is not possible to dynamic management of display is not possible. So it will be some kind of technical problem. Okay. And this is some kind of additional feature in OpenGL SSC, the single precision extension, and then the paletted texture. So 8-bit the color format is supported in as a paletted texture. And I will skip some kind of some detailed technical information. Okay. I summarize that some kind of technical issues and some in OpenGL SSC features. Okay, so paletted texture can be implemented with some various kind of hardware, but the problem is after 2004, there was no graphic card supporting the paletted texture. So it means that currently in OpenGL SSC device, maybe you use your airplane in Boeing from the airplane of a Boeing or Airbus. The cockpit display, the graphic card of cockpit display is at least, the graphic card chip is designed and manufactured more than 6 years ago. So I think that we should choose the new implementation method. Okay. So currently, the OpenGL SSC drivers made like this. So with conventional OpenGL chip, and remove all OpenGL driver code, and then they develop one by one OpenGL S command on the top of a microcode of OpenGL hardware, and then they put it into some kind of a RTOS, frequently used in avionics and defense industry, like Intel Windlever's FreeXWorks or something similar OS. And another way of implementing OpenGL SSC is using conventional OpenGL or OpenGL ES driver. And on the top of OpenGL or OpenGL ES, we can implement OpenGL SSC using conventional OpenGL features and the shading language or other software implementation. Okay, we tested and concluded that even though we implemented the OpenGL SSC on the top of OpenGL ES or OpenGL, there is some kind of overhead is less than 2% or so it does not make big trouble in performance. So we can use it, but the problem is the certification of software, because we should get certification of all the drivers and softwares and implementation on each OS. It makes a big trouble. So for DO 178 certification, the implementation on OpenGL or OpenGL ES driver is very hard to get a certification. Okay. Good point of OpenGL SSC is very tiny set of OpenGL and OpenGL ES implementation, so we can concentrate on some kind of developing application. So we don't have to worry about the side effect or some kind of bug of drivers. So in case of medical application or drawing map or drawing GPS application, I think OpenGL SSC is the best solution for that. Okay, I will explain some kind of a standardization activities. Currently, working group, the OpenGL SSC working group is in a state of hibernation, so there is no other meetings and no regular meeting is not scheduled. But nowadays, some companies trying to be adapted. So 3 companies signed to adapters agreement of Kronos, Huon, my company, and ISS, and Curtiss-Wright is signed. So there are 3 adapters, and currently 1 conformant result is submitted to Kronos CTS program, my product, and so, there is some new activities. Actually, I proposed to initiate new SSC profile based on OpenGL ES to time meeting of Kronos group, but yeah, there is no conclusion yet. But quite news is that Korean government is preparing to making the OpenGL OpenGL SSC like standardization based on OpenGL ES 2.0 for defense and avionics business. So sooner or later, the Korean national standard body will start making new national standard over OpenGL SSC will be initiated soon. I and Professor Beck write a chapter in a book. The book name is OpenGL Insight. This book will be released at SIGGRAPH, I think, August of this year. Press company is CRC Press, and 1 chapter is OpenGL SSC. So if you are interested in OpenGL SSC, then you can read more detailed information about OpenGL SSC with this book. Thank you very much. This is my talk. Do you have any question?
Yeah, I got one. So there's a company named Film Software, and before that, I think it's the US. It was used to do something about like 3D graphics, things like that. But recently they changed to also make security stuff like militaries, airports, movies. And so I'm just because right now your talk is about the OpenGL SC things, and does the feeding software this company has any contact with Kronos about securities? Thank you.
Then can I answer that?
Good question. I didn't hear you.
And I think some kind of a contact from the security related company to Kronos and activities.
So, what kind of security did you mean?
Avionics business.
Oh, avionics? Well, yes. I mean, the OpenGL SC working group was first initiated many years ago. It was probably 7 years ago. And it was the avionics industry that first initiated it. We were working with Seaweed Systems, Lockheed, Honeywell, who were using Seaweed systems in the US. And it was the certification issues that Juan was outlining that really motivated them to create a smaller subset, because to safely certifying the whole of OpenGL ES is very expensive. So that's why they needed OpenGL SC. And the avionics industry is still interested, but also now we have automotive. As automotive displays get more and more sophisticated, there's another market for OpenGL SC, which is why I think that we're finding a renewed interest. And people though want to have ES2 type functionality in OpenGL SC, so I think that will be a new project that we do now at Kronos.
Actually, the avionics business is very, very important because safety is very critical. We are using airplanes, so but it is really tiny business because the making number of airplane is too small. I think. So we trying to expand our business, and I hope that to expand OpenGL SC using industry into the medical or the automotive or so we hope to expand because because it makes money. So any other questions? Thank you very much for your attention.
好，所以今天我们上午的会议就到现在就结束了。然后下面请大家一起到台上，我们合一个影。合完影以后呢，请大家到4层的一个叫月的餐厅，我们在那边有准备午餐给大家。到那边你只要讲出 Kronoscope， 他们会把您领到一个我们 Kronos 专门的一个区域，可以吧？